Let's first see how we can solve this using traditional approach, then we will go for the distance approach. So if we have to solve this using traditional approach, we'll have to first find what are the critical values of x minus 2 and x minus 3. So x minus 2, if I equate to 0, I will get critical value as 2. If I equate x minus 3 to 0, I will get critical value as 3. We know that modulus of x can be written as x if x is greater than or equal to 0. Modulus of x can be written as minus x if x is less than 0. So as I've got these two critical values, I'll have to take the number line and take 2 and 3. That has given me 3 ranges. Range 1, range 2, and range 3. Range 1 is minus infinity till 2. Range 2 is 2 till 3. Range 3 is 3 till positive infinity. Now in these ranges, I'll have to go ahead and see what will happen to x minus 2 and x minus 3. So x minus 2, x minus 3, I'll have to figure out where all they will be negative, where all they will be positive. Okay, so x minus 2 will be negative here, it will be positive in the next two ranges because its critical value was 2. X minus 3 will be negative here, and positive here. Now I'll have to take these 3 ranges and start finding values individually. So I can take R1, which is minus infinity till 2, but 2 we will add with the next one because there is change of sign here. So 2 will be added along with R2, not an R1. So I can take minus infinity till 2 without including any of them. In that range, both of them are negative. So modulus of something can be written as negative of something. So I can write here, this will become minus of x minus 2 minus x minus 3 greater than or 7. I'll get some answer here. That answer, I'll have to see what is the overlap between this range and that answer. That process has to be done for 3 ranges and finally you'll have to consolidate it. This is how we do it orthodoxically. So now let's try and do the same thing using distance approach. It will boil down to something extremely simple. Okay, so I'm going to clear this off. We're going to look at distance approach now. Now, if I'm going through distance approach, I can think of modulus of x minus 2 as distance from 2 and modulus of x minus 3 as distance from 3. So let's take the number line, distance from 2, distance from 3. Okay, now I'll have to place my x somewhere such that the distance from 2 plus distance from 3 is greater than 7. So definitely I cannot place my x in between, because if I place in between, then sum of distance from 2 plus sum of distance from 3 will be equal to what? If I place my x in between, what will be the sum of distance from 2 plus sum of distance from 1, right? So there is no way you can place your x in between. You can try and place your x outside. So I cannot place x in between. I can think of placing x outside somewhere here. Let's say I'm placing it here. And let's also say that this distance from 2, let's say this is equal to L. Okay, I'm placing L units to the left of 2. Now let me form a new equation here. That equation would be distance from 2. Distance from 2, see, we are supposed to find out distance from 2 plus distance from 3 when it will be greater than or equal to 7. Now how do I take distance from 2 here? D2 is equal to L itself, right? So I can say distance from 2 is L plus, now D3 will be what? L plus 1, because from here I'll have to, so D3, that should be greater than or equal. Now it boils down to something very simple. So let's see what we will get here. So we will get 2L plus 1 is greater than or equal to 7, or 2L is greater than or equal to 6. L is greater than or equal to 3, right? So L is greater than or equal to 3, which means I have to go at least 3 units from here, right? I'll have to go at least 3 units from here. So what will be this point then? What will be this point from 2? If I go 3 units to my left on the number line, left I'm going on the number line 3 units. So what will be this point? 2 minus 3. This point would be 2 minus 3. I'm going on the left on the number line. So this point has to be minus 1. Okay, and it is given L has to be greater than or equal to 3. So this is my range which will satisfy this condition. Okay, now that is if I'm going to place my x to the left of 2. I can also place my x to the right of 3, right? So let's see what will happen if I place my x to the right of 3. I could place it somewhere here as well. In that case, what will happen to this equation? Let's rewrite this equation. I'll get d2 plus d3 greater than or equal to 7. Now that I've placed to the right of 3, let me just say it is at a distance r units from 3. Right. So d2, write it as r plus 1. d3, I can write it as just r. Distance of 3 from that point will just be r. So I can just put r there. Okay. So that should be greater than or equal to 7. So that will be 2r1 greater than or equal to 7, or we can say 2r is greater than or equal to 6, r is greater than or equal to 3. So from 3, I have to go at least 3 units to my right. So where will this position be? It will be at 6. This I can write it as 6. And it has to be greater than or equal to 3. So anywhere outside this and equal to this is also is included. Here also this is also included. So anywhere outside this and equal to this thing will get satisfied. Now what is the question asking for? Number of integers that doesn't satisfy the inequality. So anything between this will not satisfy the inequality, right? Including 1 and to the left side, including 6 and to the right side, it will satisfy. So between this, I'll have to see how many integers do we have. So how many integers do we have between this? So we have got 0, 1, 2, 3, 4, and 5, right? Totally 6 integers we have got, which will not satisfy this inequality. So answer for this question should be 6.